So this is the baseball problem, and it is dealing with the Pythagorean theorem. So you could label this like the picture has X, Y, and this one has S. Well, we're used to seeing X, Y, Z. Okay? And it says a baseball diamond has sides that are 90 feet. And these are constant. Those won't change. So Y is 90 feet because you have home plate here and you have third base here. Okay? No worries. And then from there, your equation is x squared plus y squared is equal to z squared. And from there, a player 22 feet from third base, that means x is 22 feet, is running at a speed, so the player is here, and the player is running toward third base. So we know that the player is doing that, okay? Because they're running toward third base, their speed is dx dt. And it's 25 feet. I know it says speed, but I don't want you thinking a positive value like the absolute value of velocity. This one will be a negative because you have to ask yourself, is this distance decreasing as the player continues to run to third base? And it is. That's why it is going to be a negative, because that distance x is decreasing. And again, remember, if the position is decreasing, we know that the derivative, in this case aka dx dt, is negative. Okay? At what rate is the player's distance from the home plate changing? So that distance from the home plate changing is ds dt, which in this case is the same as dz dt. Okay? So we have our equation. We know the constant is y, so we can plug in 90 for y. We know when we derive this, we're going to get that to zero out because it's a constant. Now let's ask ourselves, should I leave it as x? Well, I will, because how else am I going to get that when I derive it? Should I leave this as z? Well, I will, because that's what I'm looking for. So we get 2x dx dt is equal to 2z dz dt. We are looking for this dz dt, and now we just have to plug in the missing pieces. This s, aka z, is going to be plugged in for the value there. And if they said that we're 25 feet away, so we have 25 feet here, we have a constant 90, we can use Pythagorean theorem, and whatever this value is, which is a squared plus b squared equals c squared, so we're going to take the square root. So this is like 8100 plus 625. Take the square root of that, whatever that is. That's going to be the value for s. And you're going to put that, or not s, but z. You're going to put that as that value right here for z. Now this x is the value, is how far are you away from third base. That's going to go here. And then the dx dt, we just have to remember, because x is decreasing, this length is decreasing, we're going to plug in a negative 25 here for dx dt. And then menu solve feature, we'll just calculate it out and find dz dt, which I know we use this for s, which will give you that value.